up on the website. Okay, and like always, again, let me start it off. My name's Jason Vandiver, Building Code Program Manager for SPEAR. Happy to have Brett Dillon on the webinar with us today. He knows more about the HERS index than anybody I know personally, without a doubt, and certainly more than almost, but maybe a handful of people on the planet. So when we originally did this, it was really just HERS index versus ERI. Well, now House Bill 3215 has thrown a whole new kink into this. And you could certainly allow HERS for code compliance, but in Brett and my opinion, that's not allowable under state law. And we'll talk about why. And then we'll talk about, and feel free to contact me if you want to maybe meet the builders in the middle, and we'll talk about that, and we'll look at House Bill 3215. But what I'd like to do is I'm just going to replay this video from the start, and we will pause this video. It's an hour and 28 minutes, the original recording. I do have this scheduled for 2 hours of CEUs today, so you will get 2 hours. If you stay the whole 2 hours, you will get 2 hour CEUs. Please type in your questions in the chat and the Q&A. We'll typically cover those at the end. If it's well-timed in the middle, we might get into one. But this should be a lots of pausing, and if again, type them in, we can pause them and address the questions as they come. But we might end up looking at 301 a little bit. We might get into the state law a little bit, but what we will certainly do is listen to Brett's previous presentation. He does have some additional information he's going to give us. And then I'm sure he will interject, and I will as well, multiple times along the way. I didn't share my sound, so let me stop the share and then start it again with the sound checked this time. Okay, now we're good to go. Brett, do you have anything to say before we get started?
Not yet.
Okay, yeah, emphasis on the
plenty to say later.
Yes, sir. Well, let's go ahead and get started.
I'm competing with two toolbars. There we go. So just as a sort of a reminder of how we got here, the HERS index was created in 1995, and it really at the time was the HERS score. And the HERS score, higher was better under that system. And then that worked from 1995 to 2006. And then in 2006, they shifted to the HERS index, where lower is better. And prior to that, they've been referencing the 1993 Model Energy Code. And then in 2006, they shifted to referencing the 2004 Supplemental Energy Code, which was not a published code. It was just a supplement. And that worked from 2006 to 2012. And 2012 to about 2014, we shifted quite a bit. We made the shift from the 2004 code to the 2006, the published code. And then in 2014 to 2016, we were operating under the ANSI Resnet ICC Standard 301-2014. And that was a real push for us. We became an ANSI Standards development organization, and we produced it took us 2 years to produce that first standard. And then we republished it in 2016 with some amendments that had taken place between 2014 and 2016. And then, that's the published version that is referenced in the 2018 code. And then from 2019 to the present, we're under ANSI Resnet ICC 301-2019. Now, the 2014 side, we were making a big push to get that standards development finished in time for the 2015 IECC code publication so that we could be incorporated into the code. And I was under a lot of super intense pressure to make that happen, but I wanted to get it right. And so we put the brakes on some things just so that we could make it as good as we could get it. And we missed our publication date by 2 weeks. And so we didn't make it into the code to be referenced in the code. So the 2015 IECC is where the ERI first came in. and it's an R406. And when that happened, they didn't have any reference standard to point to. And so there's some really loosey-goosey language in there. They're mixing energy loads and energy use, which are two wildly different things. In fact, the way it's written, the HERS index didn't even comply with it. And so that created a lot of problems for me personally, because, it was just a really poorly written. And I was at the final action hearings in Atlantic City, and that was the first time I was getting to see the language. And it was like, this was, I felt bad. Then in the 2018 IECC, they actually referenced the second edition, which was published in 2016, which I chaired that committee at that time. And then the 2021 IECC references 301-2019, which is produced under my successor, Gayatri Vijay Kumar. She's a really super brilliant mechanical engineer. So that's kind of like how we got here. And then these two competing index things are kind of crazy. Like, what do they do? Because there's a lot of confusion about that. And a lot of the confusion starts when Resnet puts out videos that says, it's like a miles per gallon sticker for your house. And it's really nothing like that. It's kind of crazy, but it calculates the ratio of energy loads between the house as it's built and the reference design. And that's all based on the calculations that are found in the ANSI standard. But there's absolutely no correlation between that index number and energy consumption. And there's no correlation between that index number and the costs. And so, if a guy says, well, my house is, got a HERS index of 50, so it's 50% more energy efficient than the code home, well, maybe. It's not going to cost 50% less to operate. It's not going to use 50% less energy, because energy loads don't use energy, but they cause energy to be used. And this has led to quite a bit of issues in the energy ratings industry, because none of the software developers can agree on what those loads actually are. What elements in the building actually cause those loads. So that's always been a thing, and probably something for a future discussion. And one other thing that they had to do was they had to dumb gas appliances down to equal that the efficiency of electric appliances, because of the so-called fuel wars. And I got accused one time of trying to reignite the fuel wars, and which was funny, because all I did was I let a guy from National Renewable Energy Labs do a presentation at one of my committee meetings. And the fuel wars, the gas versus the electric versus gas. I've talked to groups on both sides, and it's really a moot point these days. But we still dumb the gas appliances down to create this level playing field. And then we also make a lot of assumptions about the home in there. So basically, when the energy raters are out there doing their work, and by the way, the work that they do is absolutely necessary. So I don't want anybody to get the wrong impression. But when the energy raters are out there doing their work, they're collecting about 250 data points on that house. And that goes into the software. And then the software puts it through a translation layer, where those 250 data inputs are turned into about 10,000 inputs into the calculation engine, which then spits out, does all the crunches, all the numbers, and spits out the actual index number. So there's a lot of assumptions that are happening behind the scenes that most people are unaware of. So just to be perfectly clear with everybody, the HERS index and the energy rating index are all about energy loads, not energy consumption, not energy use, and not energy cost. The energy consumption, energy cost falls under the performance path in the code, which is found in R405. So what's the difference between the HERS index and the energy rating index? Big differences. The reference design is huge. So the HERS index references the 2006 IECC, but the energy rating index modifies the building envelope for the reference design. In the 2015 IECC, they referenced the 2009, same in the 2018. In the 2021, they referenced the 2015 minimum requirements, sort of. Ventilation, there are differences between how ventilation gets calculated, because again, in the code, there is language in the code that says you have to follow this calculation, not the calculation that's found in ANSI 301. And the frequency with the updates, the code references the published version that was published at the time when the code gets put through. Whereas in the Resnet side, in the HERS index, in the proprietary system, there is a constant, it's under continuous maintenance. So there's constant updates that are going in, modifying those calculations on, about every 3 to 4 months, the calculations are getting modified. And what happens then is you end up with differences in.
So one of the things I'd like to point out here is Resnet actually has sort of like 2 sets of books. So there's the one standard that's the American National Standard, the ANSI standard that's referenced in the code, this wonderful document. Then there's the MNHERS standard, which governs the calculations for the HERS index. So
let me ask you, can this right here calculate a HERS score?
No, it can calculate an energy rating index. A HERS index is based off of this. It references most of the equations in here, but then it modifies and adds new equations in there as well under the MNHERS standard. So with the ANSI standard, you can only get an energy rating index. The HERS index, again, is the proprietary system that goes through their the MNHERS standards that Resnet has, which are their proprietary copyrighted standards. And one of the big challenges that we have there is, for example, since House Bill 3215 was adopted, this piece of legislation was passed, the MNHERS HERS index calculations have been updated 11 times.
Okay. So when a builder is telling a permit clerk or code official that you will accept HERS for code compliance, because that's what HB 3215 says, and then HB 3215, this is right here, the language that says, hey, yeah, you can calculate the energy performance of a dwelling by ANSI Resnet 301, which is this, and this does not calculate a HERS score.
Correct.
Yep.
So
Okay.
it's very misleading for people to say that the HERS index is a code compliance path, because the legislation correctly references the American National Standard Energy Rating Index, not the proprietary frequently modified HERS index, which, by the way, then also has created this weird thing where the index values on the HERS side keep getting lower with every new modification that they make to the ANSI standard. For the MNHERS side, the HERS index numbers get lower, even though you didn't change the house and you didn't improve any of the efficiency levels of the house, and the energy consumption didn't go down, energy cost didn't go down, but the HERS index goes down. And so
on the MNHERS is an ANSI standard calculation as well.
No, it
Okay,
absolutely is not. It is
I didn't think so.
very copyrighted, internal
Yep.
to Resnet only HERS index calculation.
Okay. And everybody on the webinar, I will send you a copy of the slides, and then you will also get a copy of this. This is House Bill 3215 incorporated into 301. I've got the original language, I've got the law itself, and then I have the intent statement down here at the end. Now, certainly the intent and some like questions and some areas to think about. So it's just kind of a guide. Certainly the intent of House Bill 3215 was to make HERS allowable for code compliance. I think particularly in cities that are going to move to the 2021. But anyway, anything else before I get back to the video, Brett?
Yeah, well, even if you disregarded the House Bill 3215, if you're just looking at the straight language in the IECC in IRC Chapter 11, it references the ANSI standard, which the HERS index does not conform with either.
Right.
Which
there's
so
just
no
way that a HERS score is compliant in your mind.
But you can get an energy rating index from the same people that are delivering the HERS index, as well as from some other folks. You can get an energy rating index. So, it's like, it just seems weird to me that that people would be disingenuous and claim that the HERS index is a viable code compliance path when it isn't. And, you know, just based on what the legislation says and what the code books say, you know, of course, it's always up to the local code officials. You guys can, you know, if red houses meet code today, then you can, you know, you can do that if you want, but you're not going to get a lot of support, I think, from the legal system should something go wrong. Or, you know, the bigger risk to me is when, or for me to think about, is the one that I really do think about, are class action lawsuits against builders. Because when homeowners discover that the home that they thought was code compliant, and then it turns out not so much, that puts the builders at a huge risk. And you're not improving any of the energy efficiency in the homes when we see the HERS index numbers dropping like they are. We've been doing some work recently with National Renewable Energy Labs, and we're seeing 5 to 10 points difference between the HERS index and the energy rating index that's calculated using 301, and the HERS index calculated using Resnet's MinHERS requirements. And so basically houses that appear, if you looked at the HERS index, they appear to be code compliant, but the reality is not so much. We had one house that we were looking at yesterday. It just, you know, it was stunning. There was almost a 20-point difference between the HERS index, which made it appear to be code compliant, and the energy rating index, which it clearly was not code compliant. I'll shut up now.
Yeah. We'll get back to it.
And so here's one of the things that you should probably pay attention to. And you guys can read that. So when you're done reading it, Jason, if you could just give me a signal, and I'll use you as the benchmark.
Yeah, you're making fun of me here. I remember this.
Yeah, that's kind of what we see, huh? I'm done.
Okay. Well, I assume everybody else reads as fast or possibly as slow as Jason.
No.
So I pulled together some reports. So I randomly selected some houses to show you guys what that means, right? Because if code officials are accepting the HERS index as an energy rating index for code compliance, they can be wildly wrong. So this is the actual same house, identical house. I mean, this is the house. This is the report. And you can see on the HERS, the home energy rating certificate, the HERS index score was a 54. And if you look over on the 2018 code compliance report for the energy rating index, you can see that it says the maximum energy rating index for code compliance would be 57. This house scored a 61. But if you were using the HERS index and not the ERI, you'd say, oh, this house complies with code, even though it didn't. And one of the big challenges is the HERS index is just a measurement system. It's just an index, and there's no compliance requirements for the mandatory requirements in the code at all. There is no pass fail on the HERS index. You can have, the worst I've seen personally was a HERS index of 310. That was a rental house that I lived in that had been built in the 1930s. And I've worked on projects where we've gotten houses that were a negative 45 because of all the PV that they added. They literally built a bigger porch roof so that they could have more PV so they could get a really low number. And so all of that comes into play. And if code officials accept the HERS index as an equivalent energy rating index, we run into some serious problems.
I'm particularly missing something here, because this is, I'm looking, okay, it's an Ecotrope report, and this is from the 2018, where, and I understand what the title of this presentation is and where we're eventually going and what we're going to learn, but I evidently was mistaken. Without PV on here, I thought ERI and HERS would be the same, and I'm clearly wrong. Anyway, obviously you're about to tell us, so I apologize. Go ahead.
Yeah, because it's, we'll get into actually why that all happens. So then I took one house that was rated by one rater, and I bounced that house in the software to all these different locations in Texas. And so that we could see the difference, the index variations between the HERS index and the energy rating index. And this house, by the way, is the most tested house in Texas. It's been tested about 300 times, roughly. It's my personal home. So we're confident in the data, unlike a lot of other ratings that you may run across. We're confident in this data. But this is what happens when we bounce that house around Texas. So when you get done reading the table, Jason, just let me know.
Yeah, and we did a deal. I mean, you've read, I'm sure, at least read the synopsis, that DOE variability report we've done, but this obviously is totally different. This is one house just placed in different locations. Did you use Ecotrope for all of it?
Yeah, this was all done in Ecotrope. And so one of the other things that we've been running across recently has been this challenge with the Resnet approved software tools. So because they're producing two different things. So like, for example, Ecotrope, they use this same calculations for the ANSI 301 2019 energy rating index as they do for the 2014 energy rating index. But the second edition of the 2014 energy rating index, which is the one that's referenced in the 2018 code, because it was republished in 2016, uses a different set of calculations. And it's like, this doesn't make any sense. You know, there's a lot of fuzzy stuff happening in there. And then we found some other interesting things that are happening in the software tools. Some of the software tools are making the reference home worse than the standard actually requires them, the 301 standard, so that the rated home appears to be much better, which again is going to give you a lower index number. We've got one software tool. This is a really interesting thing that we've discovered recently. If the rater goes out and the builder's got 2 3/4 inch brick veneer, if that rater does something really shady and calls it a 3-inch brick veneer, the software tool gives it a thermal mass effect. And all of a sudden you go, if you have this, what's actually there, 2 3/4 inch brick veneer, the house, like we looked at one house and it was not passing the cost performance path by 9%. It was missing. It was 9% worse than the cost performance path would allow with a 2 3/4 inch brick veneer. But call it a 3-inch brick veneer, and that software tool goes, oh, that's thermal mass. And now all of a sudden it's passing the cost performance path by 0.8%, even though the code clearly calls out that brick veneer is not allowed for mass. So there's all these kinds of weird things that are happening that you know, we're digging in there and we're noticing that there's a lot of things that are driving these variations farther and farther apart. So the HERS index is always lower and the divergence is getting greater. And one of the reasons why that's happening, and it's just this thing where people have gotten confused about the purpose of the measurement and they're chasing the result. The whole point of the HERS index and everything else was so that we could help builders build better homes, more energy efficient, less pressure on the grid, all of these cool things that are in the code, reduce cost to the consumer, these things that are in the code. And yet when they realized they could just fiddle with the equations and do that without actually having to make the houses better, reduce the cost to the consumer, save energy, reduce the pressure on the grid, just fiddle with the equations. Which one do you think is easier and less costly?
Right, especially as cities move to the 2021. Well, hey,
Yeah.
we got this with problem solved.
Yeah. You can cure homelessness the same way if you just call them urban campers.
Okay. You ready to get back to it?
Yeah.
There we go.
which, in full disclosure, they're a past client of mine. I helped them, our marketing brand did a bunch of research for them, and we helped them get to where they are, which is roughly 60% market share in the energy rating software side of things. They use a proprietary calculation engine. I did a bunch of research, and I've got some white papers that we've written on the differences between the different software tools from Energy Gauge. We ran comparisons between Energy Gauge, REM rate, Ecotrope, and now there's, of course, more software tools coming onto the market that use Energy Plus, which is produced by the Department of Energy. And again, that's an entirely different probably presentation to get into as to how these variations happen. But just this one house getting bounced around, you can see, it ranges from 5 to 7, but it's mostly 6 points difference between the HERS index and the energy rating index, and the HERS index is always lower. And it seems, when we look at the data, it seems as if Resnet is pushing they're producing their calculations on their proprietary system so that their HERS index will always be lower than the energy rating index. I've never seen the HERS index higher than energy rating index. It's always lower. And every time we get a new version of the software, the HERS index seems to drop just a little bit more. And so we can track that, and we have tracked that over time. So Resnet markets itself as, the HERS index is the gold standard. It's the one that all the builders are using. The energy rating index turned out to be a competitor of theirs that they produced, and it was cannibalizing their own, revenue stream, which it makes sense that they'd want to do this, but it also doesn't make sense. From a building science perspective, you would think that everything should line up, but it doesn't.
Well, like I said on that project we did, it won't even line up on the same house just because of, well, and I did read that article that you wrote about the, is that good data? That was a good article. By the way.
Yeah, well, there's a future presentation there for you. So this was actually what we did in this table. I pulled different raters in different climate zones, just one of their houses around the country. So you can see that this isn't just something that happens in Texas. Again, you can see in this particular situation where we're not looking at one house, we're looking at different houses. In El Paso, they get a 7-point variation. In Corpus Christi, that particular house was a 6-point. Fair Oaks Ranch, they got an 8-point difference. Auburn, Alabama, this is actually for the university there, a project that they were working on. They got a 5-point difference. Out by Nashville and Brentwood, they got a 9-point difference. And one of our PhD mechanical engineer clients, that's an energy rater, up in Aberdeen, Maryland, 13-point difference between the HERS index and the energy rating index. So this isn't something that's an isolated thing. This is a constant thing. Ryan Mears is absolutely right. They will always be out of sync to some degree. My point is the degree is often more than people think it is. And that's can be a real problem, again, if code officials accept the HERS index as an equivalent to the energy rating index, because most code officials don't understand what the HERS index is. I'm confident in that because most energy raters don't understand how the HERS index gets calculated. There's Philip Ferry, who's the architect behind the HERS index, and I sat down one time and made a list of who knows how this thing works. And we could count them on all of our hands, all the fingers on our hands. That's how many. There's probably more now, but most people just assume that it's an energy efficiency thing that governs based on energy consumption, energy use, lower utility bills, percentage reduction, and it's not a one-to-one comparison at all.
I'll never forget the look on Philip's face. I was sitting next to him at the Resnet conference when the board of directors meeting, when Jeremy Williams with DOE gave a synopsis of our HERS variability study. to the board at Resnet, the look on his face. I wish I could remember what it was he said, but you could, he was not happy. I'll put it that way.
Yeah, there were a lot of board members were not happy, and they started saying, well, the study was invalid. They actually commissioned another study to study that study to prove that that study was invalid. And and then the technical committee side, we're about the science, and we're about math, and math is not science. Math is fact. Science is a lot of guessing.
Right.
And you're always trying to prove your hypothesis in science, not confirm it, so that you can reduce your confirmation bias. And so we actually had a guy that was on one of our subcommittees. Every time we would go have the Resnet conference, he'd put together a group of raters randomly. He would just, they'd volunteer, and they'd go out and rate a house. And then he would collect the data on all the ratings that they did on those houses. And then he'd do these comparisons. And the numbers were all over the place. And so the variation is there. The variation between the HERS index and the energy rating index is caused by the information on this table. And again, this just goes to show that there's a lot of differences in the way the standard that is referenced, the 2015 ERI, there was no reference standard for it. And like I said, if you read that language that's in the code, the HERS index does not comply with that language. And, and that was a real problem, because everybody was running around saying, well, the HERS index is basically the 2015 ERI is the HERS index. And I read that language and was like, yeah, when hell freezes over.
Right. I had the Pacific Northwest now.
So HERS index, Brett, on this column, HERS index, I mean, you just told us that you cannot calculate a HERS score with ANSI Resnet 301-2019, yet you list reference ANSI standard under HERS index as that. Can you elaborate on that?
Yeah, absolutely. So the HERS index, they reference the ANSI standard 301-2019 in their proprietary copyrighted MinHERS standard. And then they amend the calculations. They amend what's going on there.
Gotcha.
So they start basically at the same point, but then they add things to it and change things so that it's not the same thing anymore. And that's unfortunate, because they're recently launched their new process for developing standards. And it's not a good process. They're going to push things to get out to the market, and then they're going to fix it with amendments, which means there's going to be more instability. Instead of taking the time to get it right the first time,
right,
there's going to be more instability, more amendments, and even greater divergence, because they're going to be making these amendments to the MinHERS standards and not to the ANSI standard, not to the published standard.
Even though a HERS score has a quote unquote competitive advantage because it's lower than an ERI score, do you think in hindsight Resnet wishes that they would have just, starting with 2018, calculated HERS and ERI the exact same way and just kept them the same going forward?
Actually, I think they think the opposite. They've given every indication that they're doing this to maintain a competitive advantage, because it's just going to be a matter of time before they have a competitor in the marketplace. And their competitor is going to have to use the ANSI standard, because Resnet owns the MinHERS HERS index calculation method. Mm-hmm. So their competitor is going to have to use the ANSI standard. And as long as they've got a competing product that is accepted by code officials and is a lower number, so it's attractive to builders, even though it got there just by fiddling with equations instead of actually improving the house, it just kind of is like this weird thing that it's like, I understand why they do it. I just wish they didn't.
Right.
You'd think that they would just can the HERS index and go with the energy rating index and improve that system. But
that's not proprietary.
It's not proprietary. So, and they make a ton of money off of this.
Yeah. Okay. All right. We'll get back to it.
National Lab told me the other day in an email that ResCheck calculates per R405, it does the performance calculations. But then when you go and read the code, what has to be included in the performance calculations? And then, well, how does Resnet ResCheck do code compliance performance calculations when it doesn't take into account HVAC? I mean, that doesn't.
Yeah.
How that
Yeah.
I can read. I'm sorry. I know you're PNNL and I know you're claiming that it's code compliant, but I can tell you that it's not.
Yeah. And, and it's this kind of confusion that gets out there. And, and a lot of times we have to deal with this. My clients, the energy raters, they have to deal with it in a lot of jurisdictions because their competitors are claiming one thing. I mean, we just literally just last night, we had a ResCheck email to us where in in Fredericksburg, Texas, there was a person submitted a ResCheck claiming R13 continuous insulation on the walls and R38 continuous insulation on the attic floor.
Oops.
And we're going, there's no way in hell that's even possible. And to their credit, the city of Fredericksburg, the code officials were kicking it back, saying this isn't good enough. This is not it. This is not it. And we got copied into this email exchange, and the code officials were holding the line saying this does not comply, this does not comply, this does not comply. And the energy raters saying, yes, it does. I'm an energy rater. Well, it turns out the guy that's doing it is not an energy rater. We looked him up in the system, and he hasn't been an energy rater since 2017. But he's out there pumping out res checks that claim all kinds of wild stuff.
Yeah.
And this is, it just contributes to the confusion in the marketplace. What the hell are code officials supposed to do? This is not their area of expertise, and they're relying on energy raters for that expertise, and yet they're not getting it. Half the time they're getting God knows what. And half the time they're getting good advice. How do you know it's good advice?
Yeah, and adding all this confusion, I mean, to me, it just degrades the validity of the energy code generally, which to me is almost the greatest ill that is afforded by this confusion and this. I mean, frankly, to me, it's way too complicated, especially the commercial chapters. But I think if it was, well, I don't know. I got lots of different ways to think about it, but in my world in which I travel, the energy efficiency world, all of the folks, it's got to be performance. It's got to be performance. And just my possibly pea brain mind, I don't know what it is, but I'm just thinking, well, if we had just some minimum prescriptive requirements, wouldn't that just be a lot easier for everybody?
Yeah, and so back when I built houses in Tennessee, I looked at the prescriptive path. It was like, this is the worst thing that I can legally get away with building. I can do better. And that's just the way I always looked at the code. The code is not the ceiling, it's the floor. If you build worse than that, you deserve to be put under the slab. And so I worked with my code officials when I was building. I'd go down and I'd have meetings with the chief building official and all the inspectors saying, here's the stuff that I want to do. And it's all beyond code, but I want to make sure that your interpretation and my interpretation are the same. So that's what I did. And my houses, by the way, were awesome because the code officials were able to help me figure out where I could make improvements, and which trades I needed to make improvements with. And in addition to that, they also helped me figure out that there's a better way to build. And so they became one of the best resources I had as a home builder. And in fact, I had a committee, a construction committee that I had to report to. I was building Habitat for Humanity homes, my last construction job. And I got the chief building official to be on the committee for me. And so he would give, he was there to put in You know, from the code perspective, when we're doing advanced things, beyond code things, whether we should or not. And that input was valuable, super valuable. And I always just looked at the prescriptive path and said, okay, how do I beat that? And as long as I did better, I was awesome. And then things get really confusing when you start plugging in software tools that does who knows what. And you've got different people putting in different inputs that produce who knows what. And now all of a sudden the code officials can get really confusing very fast.
Oh, real fast. I tell, when I'm giving builders a conversation, a presentation, the total UA path, I'll tell builders, oh, I can make your home comply in Dallas, Fort Worth, climate zone 3, no problem with you find some old R11 bats for sound, we can put those in the wall, and we can just do like a R13 cavity bat in the ceiling, as long as 80% of your walls are 20% better than code windows, you'll comply, total UA. And they're looking at you like, what? That house is going to be an energy pig. Yeah, but look at the way the total UA calculation works.
Yeah. And that's, you know, and it's crazy, you know, from my end. And you know, you guys got to understand, I've been up to my eyeballs in this for, you know, 20 years. And I look at it and I go, you know, for me to figure out you know, what's the best way to build a house? How do we get energy efficiency baked into the system the easiest way, the least amount of confusion? Let's make it easy for the code officials. Let's make it easy for, you know, for everybody. Let's make it easy for the builders. You know, following grandma's recipe, if you follow grandma's recipe every single time, you're going to get grandma's cookies. And that's basically what the prescriptive path in the code is. And if you beat that, if you can do something better than that, then you'll have something better than grandma's cookies. What an awesome deal. But when you start deviating from that and you start getting into this, and you know, I had one builder client one time, it cost him more in my time alone and in the extra things in the time that he wasted trying to figure out how he could build a house for cheaper. It cost more money just in my time and the advice that I was having to give him, which always ended up saying, no, you can't do that. You know, don't do that. Don't do that. Don't do that. It's just insane. And of course, there's the work that the energy raters do, absolutely important. You know, having them out there, they're trained in building science. They're trained to do the blower door test. They're trained to do the duct leakage test. They're trained to do ventilation testing. They're trained to look at the house as a system, to find the air leakage paths, to give advice to the trades to fix this, correct this. The HVAC contractors, they're trained to work with all those trades to make this a smooth process. The work that they do is super valuable. The test results, the performance tests that are required, super valuable in the pursuit of energy efficiency. Where things start to, you know, come apart is when we get into the software, when we get into the tech. And so this is, again, why does this happen? Well, this table right here explains exactly why we get these big differences in the energy rating index and the HERS index.
I see that mechanical ventilation. I see that in that data project we did, and when I'm doing field training and just across the board. And frankly, I go on a 15-minute mechanical ventilation rant, how it's broken the code and can't be fixed because it's based on occupant behavior. But when you look at the chart, anyway, long story short, just look at the variety in the column, in your mechanical ventilation column. I mean, look at the differences there. I mean, it's just, and then in the 2021 energy code, you're going to, that is, the HERS raters will be happy to be working in jurisdictions that move to the 2021, because while you're there doing duct and blower door, you will need to test the mechanical ventilation as well.
Yeah, and most of them are testing it now anyway, but now they can justify getting paid for testing it, because in the HERS index system, we have to test the mechanical ventilation, because that's one of the 250 data points that gets plugged into the software.
And additionally, I just sent off to ICC for an interpretation on mechanical ventilation, where as I've been giving presentations about the 2021 energy code, as I first read it, the first several times, to me, it was just the whole dwelling mechanical ventilation that was required. Once you get below 5 air changes an hour, whole dwelling mechanical ventilation is required. And that mechanical ventilation in the 2021 has to be tested. Well, CT pointed out the other day, I was giving a presentation in Pflugerville, and he goes, no, all the mechanical ventilation. And I was like, no, it's just the mechanical ventilation that's required. Anyway, long story short, sent out to ICC for an interpretation. And sure enough, all of those exhaust fans will now have to meet the CFM per watt efficacy requirements in the energy code. So you imagine a 5-bedroom, 7-bathroom house. For the energy raters out there, that's 7 exhaust fans in the bathroom, and then 1, if there's a whole dwelling mechanical ventilation fan, that's conceivably 8 different airflow tests added on to that house. To me, and granted, I'm fluid in a lot of the ways I think about a lot of this, but to me, I fall off the wagon and become a building official again. I think I would exempt some of those bath exhaust testing requirements with the caveat that, that bathroom is on an exterior wall and has a straight, unobstructed duct run to the outside. I don't know. I could see maybe lowering the onerousness of some of that ventilation testing. Do you have any thoughts on mechanical ventilation testing generally, Brett, or anything to add before I hit play again?
Yeah, I like your idea with the bath exhaust fans. Unfortunately, most of the bath exhaust fans are installed by the electrician, and then the HVAC guy runs the duct, and the electrician doesn't care which direction the outlet is pointed. So it's often right up against, a ceiling joist, or it pointed in the wrong direction. So now they have to put a, 180-degree bend in the duct, which creates a lot of friction. You don't get hardly, you basically cuts the airflow in half, or 60% less than what it's supposed to deliver. But again, these things they can be spotted if it frame. And
yeah, that's the carrot approach. Hey, electrician, it doesn't take any more money to install this exhaust fan the right way, and just the exterior bathroom with the straight shot. Then why test that? Right? Yeah. But it encouraged them to install it correctly.
Yeah. And then one of the other challenges that we've had have been with testing kitchen range hoods.
That is an exception in the 2021 FYI, folks. That does not have to be tested for a CFM efficacy. But if you want to know, you've got backdrafting, you do have some other issues where you might want to test a range hood. But I just wanted to let folks know that was an exception. Go ahead. Sorry.
Yeah. Well, one of the big things that we found was that they were installing, the integrated with the microwave range hood system, but they weren't flipping the motor. So it looks like it's vented to the outside, but it's really just, the forehead greaser and the Acme 3000. And it's like, it's like, seriously, guys, you have to install it differently. And it's, if you rip open the package, the installation instructions, rip it open, it tells them what they need to do. But we often found those integrated range hoods, we'd go to test them, and it's like, well, they're moving air, but it's right back into the kitchen.
Yeah. Well, that would certainly be an amendment. There would be no recirculating range hood exhaust. I don't care what the manufacturer says if I fall off the wagon. All right, we'll get back to it.
And that's kind of the wacky thing. And again, there's a whole presentation to be done on how ventilation actually gets calculated, because a lot of people get confused by that as well, particularly when it comes to the software inputs. So there's another future presentation for you. So this is what we're faced with. Why do we have these differences? Well, they're all calculating different things. And if you calculate different things differently, you're going to end up with a different result. That's guaranteed. And this is the big result. The HERS index does not comply with the code requirements for the energy rating index, period. there's no way. And it's a little bit troublesome when we have jurisdictions that mandate a certain HERS index number, and they say, well, as long as you hit this HERS index number, you're code compliant. And it becomes a little problematic because the HERS index doesn't have anything to do with the code other than they have a common standard that they're both based on, but they diverge. And so we get wildly different things. And, you know, it's a huge problem. It's a really huge problem for us. So I think I'm done, but I wanted to leave a lot of time for questions because I know there's probably going to be a lot of questions.
Well, I've got a few. So can you tell, so just energy load versus energy use differences. I'm just trying to get my head totally wrapped around that concept and what you mean and how energy load. Again, can you elaborate just generally energy load versus?
Before he does that, since the screen is black the whole rest of the time, so I want to hop on here and put this picture up just to have something on the background of some fun while we get back to this.
Does energy use differences?
Yeah, so energy loads are those elements in the building that are going to cause energy to be used, but do not themselves use energy. So if you think about it like this, the wall of the house doesn't actually use energy at all, but it can cause energy to be used because if that wall has less insulation or more insulation in it, it's going to change the difference. It's going to change the difference in the amount of heat that moves through that wall.
Okay.
Your HVAC system uses energy. So, you know, is it an energy load? No, but the demand for cooling in the house, like dependent on the thermostat settings and the weather outside, the demand for cooling in the house is a load because that's going to cause the HVAC system to use energy to drop the temperature. So these are the kinds of things that are the differences. And you know, that's the real challenge is when every software vendor out there has a different set of things that they say are energy loads,
Yeah.
then you end up with this big problem because none of them agree. So you end up with great divergences between software tools alone.
Oh, yeah.
And it also creates what I think is probably the bigger challenge, which is when
Well, that's going to incentivize other software manufacturers to tinker with that load. I mean, there's going to be a race to the bottom, right? I mean, with a HERS score versus other software manufacturers and what they're trying to spit out as far as a number.
Yeah, in fact, so the Resnet software tools have to pass what's called it's the ASHRAE Standard 140 test. And right now they've got the acceptance criteria are pretty loose. You know, if it was a test for a car, it would let a jalopy and a Ferrari both in,
Okay.
because you know, they got 4 wheels, they got a steering wheel and a combustion engine. So Resnet's got this software consistency task force headed up by Neil Cruz, and they're really trying to tighten that up. But one of the software vendors on the Resnet software tools is refusing to go with the tighter test acceptance criteria because their software tool can't pass it. And their argument is, why should we have to pass that test when we get low numbers? And it's like, well, it's not about getting low numbers. It's about, you know, are you calculating the physics correctly? And so there's this big debate. And so Resnet has said, we're going to adopt these tighter test acceptance criteria from the ASHRAE Standard 140 test, but then they've never set a deadline on it, and they're not pushing to make any of the software vendors conform with it. So it's an interesting thing that, you know, we're starting to see sort of, you know, gamesmanship in the system, trying to manipulate the equations to get lower index numbers instead of, and in fact, the Resnet software tests as a whole do not require the software tools to actually use the equations in standard 301, which I always thought was a bit odd.
And I will say that again.
So the Resnet tests in the software, they don't check to see if the software tools are using the equations in standard 301. They just have to have outputs that fit inside this range of a software tool that does those equations. So as long as you're close, you're good. You just don't have to use the equations. And so it's an interesting challenge. And you know, I've been working with some tools and, you know, playing around with some things, looking at different things and trying to figure out how can we improve this system. And even though I stepped away from everything Resnet in the end of 2017, resigned from all my positions, you know, the work that the energy raters do is incredibly important. They're an incredibly important resource to code officials. They're an incredibly important resource to home builders. You know, it's just that they get stuck in a stupid system that, and what I mean by a stupid system, it's a system that doesn't recognize when things are not being done correctly, and it doesn't allow people to correct them when they find out. I mean, there's even cases, you know, for example, cases where, you know, code officials have suspected that, you know, an energy rater was committing, you know, writing down fake test numbers and reported them to Resnet, and they do an investigation and they find out, yeah, he has, and he's been doing it on dozens of homes. There's literally dozens of cases of this, but for some crazy reason, instead of landing on that guy like a, you know, ton of bricks, they said, you can keep, it's in the best interest of Resnet and everybody involved if he keeps doing business. And then he gets caught again. And it's just in the best interest. We'll just put him on probation, and it's in the best interest of Resnet that, you know, this guy keeps doing his stuff. And it's like, well, that's a stupid system. You know, if a guy's caught cheating and admits to committing fraudulent ratings, the code official knows, Resnet knows, why isn't something happening to this guy? You know, I mean, like, you either do what you say you're going to do, or you just can the whole thing. And that becomes, you know, so you couple that with, you know, this thing that's happening over on the software side. And, you know, and the reality is the number of raters that are out there that somebody should probably take a really close look at, it's pretty small.
Yeah. My experience, most of those, all of them that I know are doing a good job and wanting to do it right.
Yeah. It's just they're sort of stuck in this system that doesn't give them the tools that they need to help them do their job right the first time. You know, Resnet's whole thing on quality management, for example, is retroactive, catching people after they've screwed something up, not helping prevent them from screwing something up. Yeah. And it's the same thing, it seems like, on the software side. And it's just like, you know, it's a real challenge.
Yeah. All right, we'll hop back to it.
Builders are marketing their homes, and they're using the HERS index as a thing saying, well, your home is going to use 50% less energy because you've got a HERS 50. That's not true. Yeah. In spite of the fact that Resnet put out a video that says that, that's still not true.
Right. Yeah. But did you see the video? It did have some pretty good graphics. That doesn't make it true.
Yeah. I mean, you can have, I mean, they spent a lot of money on that. And the sad thing is they spent the money on that, and then they showed it to me and Philip, and we said, this is completely wrong. And they're like, yeah, but we've already spent the money on it. I was like, okay, but you spent the money on something that's wrong. Don't put it out there. Yeah. And it's just, you know, ridiculous. The kinds of things that we see. So that's, you know, Resnet is contributing to this kind of confusion in the marketplace when they send those messages out there and they put those videos out there that builders are relying on, you know, and on the marketing side. So, you know, I always have this big fear of, you know, one of these days that the wheels are going to come off of that bus and a bunch of people are going to, you know, go together and sue a major production builder because of their marketing claims, which are based on stuff that's not true.
Yeah.
And I probably shouldn't have said that, but I don't care.
Yeah.
It's the truth. That is a huge concern of mine. And that's when I go to builders and I talk to builders. I say, listen, don't market your homes that way.
Yeah.
Don't do that. You're in trouble.
Yeah. Yeah, we don't see, in Texas, we don't see too many. And for code compliance, we see close to zero homes submitting ERI pathway for compliance. Not literally, no exaggeration, 99 out of 100 homes in climate zone 3 are R405. I mean, they're not R406. So they're using the performance path. Yes, they have a rim rate HERS. They might have a HERS report from Ecotrope or rim rate, but the compliance path chosen for permit is almost always R405, especially in climate zone 3. Climate zone 2, you actually do have most builders using total UA and res check, but there's still a handful. I had Top Build at my presentation in Victoria on Tuesday, and I asked Top Build, who does a lot of homes in Texas, how many they anticipate submitting using the ERI path for permit, and it was 0. How many did you submit last year using the ERI path for permit? 0. It's all 405. And that kind of lends into Andrew's question. And I thought rim rate still had market share. I know 2 years ago, rim rate had 90 plus for a lot of the market share. Andrew asked, is Ecotrope the main HERS rating software used? Did you say that it took the lead over rim rate?
Yeah, they took a big lead over rim rate. Rim rate ran into some pretty serious technical problems because they had to update their calculation engine. They had to switch to an hourly calculation engine from their proprietary system, which was built on software from the 1980s. So, which had been patched, and then the patches got patched over the years. And when they had to basically take it down to the foundation and work with this new calculation engine, they ran into real serious troubles, and they lost a lot of market share because the numbers that were being spit out were just ridiculous, and their development time to get it to be compliant with ANSI 301 requirements for an hourly calculation simulation engine, it just really it hurt them a lot.
Yeah, wow. Yeah, and then I'd heard, and I think they were probably focusing a lot of their time on that, and I'd heard general complaints about customer service from their raters and software purchasers as well. Joseph wants to know if you can come with me to my field training in McAllen next week. I can't put him on the payroll, Joseph. He's doing this for free. I don't think he's going to drive with me.
Oh, Brett, I would have loved for you to have been in the field with me when we came across this house at my last one. Oh, you would have had some things to say. There's no doubt about that.
Yeah, I probably would have said some dirty words. Because, you know, you're right. In McAllen, they're only going to get 20 inches of rain a year, but, you know, 5 inches of that happens in one big dump. And that's a lot of water to shed off of one roof onto another roof and then get directed onto, you know, that little swampland they've built.
Yeah. So Michael asks, and I think this is a perfect question. So he's having a lot of people submit for HERS. There's a lot of builders now submitting HERS scores for code compliance. Let me get back to it. And House Bill 3215 says, now again, the intent is different than what it says. What it says is, and I'm almost there, that, so it says Energy Star, right? The
Yep.
EPA's Energy Star shall be considered in compliance. And then it says a home energy rating system utilizing standard 301 as it existed on January 1st, 2021, which that right there will not calculate a HERS score. So if they're giving you a HERS number for code compliance, you just tell them that's not, that HERS number was not calculated per this ANSI standard. Is that correct? Or how would you word that when you start telling those builders you can't use HERS for code compliance anymore?
You know, I think really the message is that the HERS index has been modified, is based on a modified version of the code reference standard. And because it's been modified, it doesn't conform with the legislative language right there. And this is, I mean, and that's fact. You can't, I mean, there's so many different ways they could have worded this that would have been, you know, much easier and probably would have reduced a lot of confusion.
I mean, wording that as just citing min-HERS, wouldn't that have been the way to go? A home energy rating system using the calculations, and but then it's proprietary and you can't.
And it's proprietary and you can't do that in legislation, right? And then when the Resnet embarked on this strategy of continuously amending 301 in their min-HERS standards to calculate the HERS index, which creates this problem, you know, it's really Resnet just needs to stop doing that. And you can always get, you know, the HERS raters can give you an energy rating index. The software tools will produce this energy rating index. They will do that. It's just going to be higher than what the HERS score is because it's calculated using 301. So, you know, you can get the HERS raters, the energy raters can do the energy rating index with the same software tools that they're using to produce the HERS index. It's just the reason why people are flocking to the HERS index is because it seems to be producing much lower numbers without actually making the improvements to the home. So.
Okay, fantastic. We'll get back to it.
Need a McAllen and not need some money.
Well,
But Brett, you are welcome to ride with me to McAllen on Tuesday if you'd like. Robert says, due to increased shortages in radiant barrier specifically, which I am happy to announce that supposedly they have caught up to the radiant barrier shortages. So those have gone away, is in my understanding, or will be going away in the coming days and or week. It says the energy compliance path being used calls for the radiant barrier. What can a builder do? Substitution. I'll take a shot at it first and then turn it over to Brett. Well, that radiant barrier on R405 is just saving a little bit of energy, just like everything else in R405. So going from R38 to R42 in the attic, I'm guessing would more than offset the radiant barrier. But a little bit better windows, any other increase in building thermal envelope or energy HVAC use items with R405, any increase in the building thermal envelope or decrease in the energy use of HVAC would help offset that radiant barrier. Do you have any other? I know the city of Austin, you're not offsetting it. City of Austin has amended their energy code to require radiant barrier in single family houses. And if you've ever been in an attic in August, that one, you can go in a house with a radiant barrier and they go in a house next door without, you will be sweating significantly more in the attic without radiant barrier. So Brett, I'd like for you to answer the question about substitutions for radiant barrier. And then I'd also just like to get your thoughts, if you don't mind, just radiant barrier in general, and your thoughts on that.
You're trying to get me in trouble with the radiant barrier guys.
No, because I have a feeling there's a truth under there that I'm not aware of.
So one of the things that we found, for example, I think the city of San Antonio has recently gotten this thing about the radiant barrier shortages that, you can substitute the shiny paint for it as long as it meets certain requirements. And, it's one of the big challenges that we have is there's so many myths about radiant barriers and how they work. You know, for example, they do not reflect heat at all. That's not what they do. I've seen so many builders put radiant barrier sheathing underneath the siding on the walls of the house. I'm thinking, huh, that was a waste of money, and now your vinyl siding is going to melt. But radiant barriers got a lot of myths and misconceptions about them. They work really, really well when they're applied correctly, but they also have a slight side effect of increasing dramatically the temperature of the lumber that it touches. So the top cords of all your trusses and all your rafters, that temperature of the wood goes up quite a bit. And in some cases, we've actually, you know, on really, really hot days, when you're in triple digits, I've measured the temperature of rafters that have on houses that have radiant barrier on the roof deck, on the underside of the roof deck. And because the radiant barrier is collecting all that heat, and it's heat greedy, and it's holding that heat, it releases it to anything that it touches, but it doesn't release it to the things that it sees. You know, the amount of heat that it releases to the things that it sees is greatly reduced. But everything it touches, it conducts heat like a son of a gun. So what we see is in those rafters that radiant barrier is sitting on, they tend to be a lot hotter. And in fact, they can reach the slow degradation temperature caused by heat, which basically means that, you know, over a long period of time, that could potentially lead to a failure in the lumber. And I brought that up years ago when Louisiana Pacific's first brought out Tech Shield. I brought that up to one of their guys and said, you know, you guys looking at this? And they said, no, why would we do that? I was like, well, you know, much like putting plastic in your walls, this may be a problem that comes and bites us in the ass in 30 years. But, you know, but it's just something that I look at and go, you know, as a researcher, you know, building science guy, I look at it and go, yeah, that might be something that we should be paying attention to.
Especially applying polyurethane spray foam. I mean, the customer changes his mind. You know, you wouldn't put radiant barrier on a house with foam typically, but if you're doing you know, you're midway through a house and a customer buys it and a customer wants foam and you've already got the radiant barrier roof deck up, well, as a builder, you're not going to rip that off. You're just going to foam the radiant barrier.
Yeah, and there's so many problems with that. You know, there was a builder that was having that issue. They were building down along the coast, and they were having that issue, and they vented the attic and everything else, and then, you know, the customer says spray foam, so they spray foamed everything, and that house had it started raining in the attic because the HVAC guy did something really silly. So it was pouring down rain, you know, it was literally water droplets. It's like misting inside the attic, and then there was liquid water coming out of the walls after they put drywall up and turned the HVAC system on. And, you know, that's a problem. And because a lot of times builders don't stop and think about the consequences of substitutions and things like that, it gets to be a real challenge. And that's where energy raters can be super useful in helping builders sort that out and helping code officials sort that out, like which materials should work. You can't rely on architects anymore. We find that a lot of architects, the amount of education that they get in building science is mostly, you know, it's a couple of hours. And a lot of them fail to understand that, you know, that connection between the materials that they specify and the performance of the homes. And one thing that we did learn a long time ago is power attic vents are the worst thing that you could put in a house because they cool the attic down by creating a negative pressure zone directly above the house, which causes conditioned air to leave the house and get sucked up through the penetrations in the attic floor and into the attic. And then on top of that, you're paying money to run the vent. And so it causes the HVAC system to run longer, using even more energy to keep the house comfortable. And then you're throwing conditioned air up into the attic space to cool the attic down, using another fan up there that's even using more energy. So one of the sneaky things, dirty tricks that we used to do a long time ago, is we just cut the wires on them. You know,
what would you think about if your ceiling was sealed really well? You did a really good job sealing all the penetrations in your ceiling, and not necessarily a power vent, but like a whirlybird type roof vent. If you had, and
So-
then the other caveat, plenty of venting at the soffit. You had like a good continuous soffit vent with plenty of net effective opening, and then you had whirlybirds in the top. What would you think about that?
So we've actually looked at this a lot. And in research done in Florida on actual houses, not theoretical computer simulation models, but actual houses, research that was been done in Texas. We look at attic ventilation, and one of the challenges is the code ventilation requirements, the minimum code, is the worst amount of ventilation that you can provide. You have to provide a lot more. You have to ventilate the hell out of that thing. And the best way to ventilate that is to have 1/3 of your openings in the lower third of the roof, and the 2/3 of the openings in the upper 1/3 of the roof. So you've got more outlet than you have inlet.
Mhm.
And the other challenge that we've run into is people have gotten away from proper ridge vents. The high profile ones, they think they're ugly. So they go for these low profile vents. But the low profile vents only work partly. They don't work all the time. And they don't work on both sides all the time. But if you have one of the high profile attic vents, they've got that lip that runs on the outside edge of it. And that lip actually, when the wind blows, it creates a Bernoulli effect. And so it sucks air out of the attic on both sides as it blows over that ridge vent. And so we actually found that a good deal was full soffit venting and a good ridge vent, and then put in some turtlebacks or turbines to help. None of them requiring any power at all.
You would be okay with a turbine then?
Oh yeah.
Yeah, that's
Yeah.
kind of my,
As long as you've got
that's
ridge
what
vent.
I advised. A coworker of mine was getting a new roof, and she was trying to determine between, just static versus whirlybird versus power vents. Oh, do I spend the money on power vents? And I told her I wouldn't power vent my attic. Heck no, I would make sure and have a good continuous soffit vent. And I'm one of the few code officials I know that has written a bunch of red tags for underventilated attics. But man, at least in the jurisdictions I've worked, I see it all the time. Or another pet peeve of mine that I've written a bunch of red tags about, and I'd advise all the code officials on this call to do it as well. If on a fully foamed house, well, if there's above the garage, typically they'll extend the wall right there at above the garage, and they'll foam encapsulate everything that's not above the garage. Well, that attic area above the garage needs to be ventilated. Or a lot of times, depending on, a big custom house or something that's foamed, you might have little, and it might only be, 40 square feet. It might not be very big, but I would always make them ventilated. I didn't feel like I wanted any stale, static, moisture collecting, unbreathable attic space anywhere in a home.
Yeah, and another place that a lot of people forget about are porch roofs. Because the problem with the porch roofs is you end up with that heat buildup in the attic. If the porch roof isn't vented, that attic over the porch is not vented, then that heat buildup transfers through the wall into the house.
Into the house.
And we often find that that's a poorly insulated wall because they forgot to sheathe the exterior before they framed the porch roof up to it, and all kinds of other issues.
Mm-hmm.
And we shoot infrared and it lights up like a Christmas tree. Like, holy cow, what's going on here? And some of the other challenges that we've seen is, and this is funny because I'm looking out my library window right now at the suspect house in question. One of my neighbors had their house re-roofed, and they didn't have any ridge vents on the house to begin with. So all they had was soffit vents and just a few. They didn't have enough attic outlets, turtlebacks or turbines. And so the roofer comes in, and I watched them do it. They ran felt paper. They ripped everything down to the deck, and they ran their felt paper, and they covered the peak of all the ridges with felt paper and the shingles, and then they nailed on the attic the ridge vent over the top of that. So it looks like the house has a ridge vent, but it doesn't.
Oh, no.
So unless you go up into the attic and look up there specifically for that, you're not going to see it. It looks like it's got this massive amount of attic venting, but it doesn't. It's completely covered up. So, so how many code officials, are going to be climbing up into the attic spaces and looking at that? Particularly like I heard from a code official in Las Vegas, they said that builders won't even provide a ladder for them to get up into the attic and look at things, because the builder doesn't want the liability if the code official slips off the ladder. And so they're relying on the builders to take photographs of things and send it to them.
Oh, wow. Yeah. That's
And I'm
crazy.
like, what the heck? Wow. Because I know what can happen. I've seen it, and then, there's, I just looked at the chat. There's one question from Robert on best energy compliance pathway, prescriptive UA performance or ERI. So we've talked about challenges with the energy rating index and the HERS index. And Jason talked about the UA calculation, the total UA calculation. The performance path has another interesting challenge, Jason, and I don't know if you're aware of it, but there is no organization that vets whether or not the performance path calculation software tools actually do what they're supposed to do. Resnet used to do that.
Yeah.
We had a publication out and we would run these tests and then we'd say, yep, this software complies with the requirements. But at the 2015 spring board meeting, I pointed out that Resnet had authorized a software tool for the 2015 code when we didn't have a publication that had been updated to accommodate the 2015 code. And I brought that up in a board meeting and that unleashed all kinds of havoc. And Resnet's decision was to get out of vetting code compliant software. So there is absolutely no organization that vets whether or not a code compliance software tool for the performance path is actually doing the calculations correctly. And so,
yeah, ResCheck doesn't, in my opinion, but even though the lab that creates it just told me that it does, but you read the code, read 405 as a code official and read the calculations that are supposed to be included in that. And
ResCheck absolutely does not.
No,
they neglect HVAC entirely.
Entirely. And so, and it clearly says, and look in section R405, you have to consider that energy use.
Yeah. I tried to get the ICC to take on, because it really should fall under the ICC, to take on approving code compliant software. One, it'd be a revenue stream for them, but two, that's totally in their bailiwick to do that.
Absolutely. And they could charge for it. I mean, why couldn't they charge for it?
Oh, they would.
Yeah.
You charge it, they could, it's a revenue stream for them.
Yearly fee.
But there's a lot, I mean, those performance calculations, there's a lot behind that. You look at the table, here's what the reference design home's supposed to have, and here's what, gets put in the, the as-built is going to be whatever, as proposed.
Mm-hmm.
But, there's a lot behind those calculations that can be fiddled with to get answers that may or may not be correct. Which is why there needs to be an independent organization that looks at that stuff, because it's incredibly complicated. The software is incredibly complicated. I calculated a HERS index by hand one time, and I was writing with a pencil and writing small. I filled up one of those entire 3M notepads before I finally got to my answer. And I took pictures of it and sent it to Philip Ferry to ask if I did the calculations correctly, and he said I did. And that's when I discovered that REMRate had a serious calculation problem, because I had a guy, a PhD mechanical engineer I've mentioned before, he actually created a spreadsheet that calculated the HERS index, and his number was different than REMRate's number, And then I did it by hand, and my number was 1 digit off from his number. So I sent it to Philip Ferry, and he said, we were right. And I was like, well, Philip, we got a problem with rim rate because they're off by like 5 numbers.
Yeah.
There's a big difference between what we got and what they got.
Yeah.
And
Well, that's a problem.
and there was just,
And that's why, I mean, there's no answer to that question, Robert, because you can build a better house by any of those 4 paths you listed. However, in my opinion, at least, if I at least get the minimum prescriptive requirements, then I at least don't have concern about any fuzzy math in the calculations on UA performance or ERI. And in a perfect example on the total UA calculation, to me, is especially egregious when you think about the intent of the energy code is to save energy. And as long as you bump up your allotted U value, your baseline U value, by putting it, like I said, I mean, we all know windows are less efficient than walls, right? I mean, they are making some really good high dollar triple glazed windows these days that are close. But typically in our market in climate zone 2 and 3, we have 0.21 solar heat gain, 0.32 U, something like that is about an average. That window doesn't perform as well as even just an R13 cavity wall. And so with the total UA or any of those other paths, if you're trading off, typically your windows are your weakest, right? I mean, but where performance in ERI, I would say those would be better. Those would be better if you're getting credit for putting your mechanicals in conditioned space, which obviously is one of the dumbest things we do in Texas, is put our piece of equipment responsible for cooling the air in our 140-degree attic. So I just don't think there's really an answer there, but straight prescriptive to where you're not trading off those building thermal envelope requirements. If you do straight prescriptive and you get your mechanicals in conditioned space and you're just using the 2012, 15, or 18 IECC, I think I'd be pretty happy with that. Well, if you, this is a good question for you, Brett. You're building your own house and today, in today's market, you're going to build your own house from scratch, price considered, obviously rammed earth and passive house and solar and geothermal and, solar hot water. Oh yeah, that's all great if we've got $1 kajillion. But if we are working from a budget, could you briefly kind of detail your floor, wall, ceiling, mechanical, and insulation plan?
Yeah, so what I do is I look at, like the basic, the code prescriptive path. That's a good place to start. And I like using the software tools to show me basically the relative performance increases I could get from different strategies. So one of the things that I found was, and I'm a really big fan of this, in spite of the fact that, I'm a 4th generation home builder and love working with wood. I'd build my house out of concrete. I'd build my house out of autoclaved aerated concrete. So I'd start off, I'd have a basement because that's going to act as a heat sink. And plus it'd give me a nice place to store all this excessive amount of wine that I have at my house. Mm-hmm. And I would look at that. And so I would have a slab floor in the basement, obviously with the sump pump and everything else. And I would have some exterior insulation in the form of fiberglass drain mats or something like that on the exterior of my basement, concrete walls, come up, frame floor, and I would put my HVAC system down in the basement. And then I would have aerated autoclave concrete walls, and I would do spray foam roof deck, or I would use sit panels for a roof deck. And that's pretty straightforward, pretty easy. Mechanicals becomes the only challenge. And
man, I love that aerated autoclave concrete. That's a fantastic building product. So I've got a question from some CT asks, so does House Bill 3215 allow you to, 1, ignore the mandatory testing requirements, 2, does it allow you to skip the exhaust fan testing since hers doesn't require that? Does it require it to be projected rating or confirmed, which doesn't require QA? You want to speak to any of those questions?
So the way I've read 3215, it does not allow you to ignore the mandatory testing requirements. And it does require you to conform with or to comply with, because you comply with code, you conform with standards. It does require you to comply with the envelope requirements of the 2018 code. But the way I read it, it was like, if you're following the 3215 path, then it seems like you would be able to skip the exhaust fan testing, because that's under the 2021 code, unless your jurisdiction has adopted the 2021 code, in which case, congratulations, you're screwed. And 3215, because it referenced ANSI Standard 301 2019. In ANSI Standard 301 2019, you have the projected rating, which is based on plans and specifications, not with any of the included tests. A confirmed rating is somebody's gone out there and confirmed that these things are as built, and they're in there. So I believe it would have to be a confirmed rating using the energy rating index. The big question then is Resnet going to require, because they own the HERS index, is Resnet going to require all of their raters to load all of their energy rating index files into their database system? That would be the question. And I'd gone around and around with the Ecotrope guys saying, hey, give us something here. Don't require the energy rating index to be uploaded into the HERS index system. If we're just doing code compliance, stay out of it. And they said no. But again, that's an internal politic thing within Resnet and the software vendors, because they all make money off of people uploading files to their system. So my guess is that they would require that. But if you're just looking at ANSI 301, it doesn't require that it be uploaded into the Resnet system, because it doesn't require any of the proprietary stuff that you see with Resnet.
Okay. I'm glad James is on. So James asks, so can you confirm that a HERS index produced in Ecotrope version 4.0.1 does not utilize ANSI 301 2019?
So I went ahead and put it in the chat, but the HERS Ecotrope version 4.0.1 is the latest version, and the HERS index values that are calculated with that use equations that are modified in MinHERS, which is Resnet's proprietary standard. So they are different from ANSI 301 2019 as published, as it existed January 1, 2021, which is what is referenced in House Bill 3215. So it's addendum 55I under the MinHERS standards. You can go to Resnet's website and look it up. There's a whole bunch of modifications that they made. So it very clearly, and it went into effect. It was adopted January 22, 2021 on the MinHERS side, but it didn't do anything to modify ANSI 301. So yeah, it doesn't do it.
Okay, and did you see James comes back and says, from Resnet MinHERS site, addendum 42 currently allows voluntary use of Resnet accredited software based on 301 2019 and will require use of standard 301 2019 on January 1st, 2022.
Sure, but they've modified it. I mean, you can go look at it. It's in their standards. They've modified it.
Yeah.
And it's the crazy thing. So when the HERS index is based on a modified version of ANSI 301, which means it's not the published version, which is what is referenced by the code. So that's kind of like the starting point. And, the second piece is, because it's an American national standard, ANSI 301, the MNHERS has nothing to do with it. That's Resnet's proprietary standards. And the software tools use 301 as the base, and then they modify it, and they keep modifying it. That's why if you go back, James, you can go back and look at pick a house, any house that you guys have rated in the last week, and then take that house and then go back 4 versions of the software, which will still be, late last year. Go back 4 versions of the software and run that house through each versions of Ecotrope and watch what happens to the HERS index, which tells you that it's not 301, because 301 doesn't change. It's a published standard. And the only time it changes is when it gets republished. And you can add addenda to it. And depending on if the jurisdictions adopt the, if those addenda are in effect at the time that they adopt the referenced code or the reference 301, then some jurisdictions say, yeah, we require the addenda that were in place at the time. Other jurisdictions say, no, we require this one. So that's the way that works. And
Well, Michael Beard asked, well, it's fascinating, and I understand the intent, and I don't know. I'm usually in the can't we just all get along kind of camp, but as I'm learning more and more about it, it just seems like it might be problematic, and ultimately I'm probably going to have to toe the company line. Michael asks, what are the qualifications for a rater? Can anyone do it? If credentials are required, is there a way to verify those?
yeah, so ANSI Standard 301 does put in requirements that they have to be an approved tester. That's the language that's there, not rater, but an approved tester. And then
would BPI IDL certification qualify in your opinion as an approved tester?
It leaves it up to because it doesn't define who can approve the tester, so it could leave it up to the jurisdiction. And that in itself can create problems. So you can find there's a lot of course there's a lot of energy raters out there. There is a way to verify them. It's kind of clunky, but Resnet does have a way on their website for you to go see if somebody is a certified rater or not. Usually you can just require them to submit their credentials along with the contact information for their QA provider. And then you can reach out to their QA provider and ask them to make sure, to verify that they are. So that's one way to do it. And, it's, because, when we were producing 301, we had to be extremely careful not to include any proprietary language in there and reference any proprietary things. So we couldn't reference Resnet's proprietary certification system, for example. So that's why we use the language of an approved tester. And, it would be nice if because I know the DOE had done some work before on certification programs for people to do this kind of work. Be nice if there was a national standard to go along with certifying folks for this. And then of course you could have that in place. And again, I'd like to remind everybody that another path for code compliance in Texas is the Energy Star program. You can always, just say, what, it's Energy Star. If it's an Energy Star home, congratulations, you're code compliant.
Yeah, that's and I want to unmute James because I know he's been in the weeds on this from the get-go, and he's super knowledgeable as well. And I'm sure it'll just allow the conversation to go a lot better if James can talk. I clicked allow to talk, James. You should be able to now. Of course, now I'm not seeing you on here.
Yeah, can you hear me?
Yeah, we can hear you. Go ahead, James.
Okay. Hey, yeah, and I apologize. I attended, well, I've been on the webinar kind of off and on. You know how it is in the office.
Oh, yeah.
Distraction here, distraction there.
Yeah.
But I pretty much got the meat and potatoes of it. And Brett, I totally agree with you, because we are in the trenches of running calculations as we speak, and HERS scores and even ERIs and everything, and compliant percentages over IECC calculations, they've changed from this week to 4 weeks ago, all over the place with these software updates. So, I mean, I totally agree with you on that. I guess my question is that, yeah, I understand what you're saying about MinHERS puts their own twist on ANSI 301 2009 or 2019. But then again, doesn't 2018 ERI and 2021, certainly 2021 ERI puts their own twists onto the reference home when latching on to ANSI 301. So, the way that I see it is you have all of these chassis and cars that you can build on the chassis, but everybody has to use the same engine to build these cars.
Right.
And that engine is ANSI 301 2019 version.
Yeah, but you could also do just what the legislation says, and you can have just a straight up 301 unmodified 301 2019 energy rating index. And it doesn't have to be modified, because the code versions or the code pathways for R406 in the 2018 and the 2021, they modify the total leakage of the house, which actually now makes the house appear to be worse than it is, which is really wacky. But I guess that's what happens when you get people who don't know how the rating index works, fiddling with things. But you can get a straight up ANSI 301 2019. The software tools have that capability to produce that without modifications, using the equations that are in 301 2019. And that's what House Bill 3215 did, was it referenced that standard without those, without having to be the 2018 version, which is R406 version, which is kind of screwy, without it being the 2021 R406, which is kind of screwy, or the loosey-goosey 2015 R406, which is really weird. I mean, you can just get the straight up 301 2019 energy rating index. It's just a matter of whether or not the software vendors will allow you to do that. And that's really the problem.
Well, what I'm being told is that Ecotrope is in the process as we speak of creating a HB 3215 compliance report. So it would be really interesting to see what those reports reveal. If they do stray away from a HERS index using the latest version of the HERS rating software alongside the 2018 backstop requirements, because I mean, remember, those are pretty robust.
Oh yeah,
pretty robust infrastructure for this pathway. And in many cases, we're finding this is more stringent than even Energy Star calculations, which Energy Star calculations are at HERS index target driven. But, that's been long established as a code compliance equivalent pathway since 2001. So, it's not setting new precedent to allow for a HERS index into our codes, because the Energy Star pathway did that already for us. I think what House Bill 3215 is doing is providing a different option, utilizing that same infrastructure, that same skeleton, but modifying it with actual concrete scores and not putting a floating score based on the reference home like Energy Star does.
Yeah, and one of the things though is that Energy Star references the energy rating index. So that's key. It's not strictly HERS index based. And one of the other interesting things, from my end, is that you can do just the straight up 301. I mean, Energy Plus does this calculation, 301 2019. You do straight ERI. And Energy Plus is the calculation engine developed by the Department of Energy through the National Renewable Energy Lab, and it's open source developed. and it's a really robust tool, and you can get a straight up 301 2019 ERI out of there. And when we compare that to Ecotrope's outputs, we see significant differences, and this causes a lot of concern, particularly when you're trying, Resnet has spent a number of years trying to drive software consistency, and yet they keep not doing the things that they need to do to get software to be consistent. And that's its own problem. The reality is that you can do an energy rating index, but the HERS index, let's be perfectly clear about this, the HERS index does not, because they've modified the equations and added equations and all this other stuff, does not use the ANSI 301 2019 as it existed on January 1, 2021, which is what the legislation says.
Yeah, and that's always been, kind of brought up as, well, they'd had to put a timestamp onto that standard when the House bill was getting written. So I think the intent, and Jason, you have the intent document on you. The intent is that ANSI standard is always going to be the latest version of the ANSI standard, on the latest software update that supports a HERS index. So that's going to evolve over time. But whenever you're putting things through the state legislature and you're citing the standard, you have to cite, to my understanding, you have to cite a date and time of what version that standard existed. And that was the reason for that verbiage there.
Yeah. However, I think if you read this, nowhere in here does it say HERS index.
Yeah, and so 301 2019, so that's from my understanding. So as a code official, if I have a builder telling me I'm going to submit a HERS score for code compliance per House Bill 3215, well, as I read House Bill 3215, HERS isn't in there, ERI's in there. So you can submit an ERI score per 301 2019, but that's different than a HERS score.
But the statute says home energy rating system index. That's a proprietary term implying.
Yeah, but the home energy rating system index is not calculated per ANSI 301 2019. It's calculated per MNHERS. Or no?
No, you're absolutely right, Jason. The energy rating index is calculated by 301 2019. And when it says home energy rating system index, home energy rating system is not a proprietary term. Those are all common terms. HERS index is trademarked by Resnet. They own the trademark.
And just for the record, James, I'm not trying to cause problems, and I love those 2018 backstops, and I'm not telling code officials do not allow HERS for code compliance, whatever you do. I mean, that's not the path I'm taking here, because I do understand the intent. And if we have those 2018 backstops, and if we've engaged a rater from plan review to CO, I'm pretty happy generally. But I can't help but say what the bill says, and the bill says ERI, not HERS, because 301 2019 does not calculate a HERS score.
Yeah, I mean, I think there's at least half of the rater network that would disagree with that, but that's for a topic of for a different time and place.
Well, I mean, the bottom line is, half of the HERS rater network could agree or disagree. It doesn't matter. The legislation says what it says.
Yeah, no, I totally agree with that. Totally
doesn't matter. And it's up to the code officials. And this is the sad thing, in this Resnet's sort of crazy ass push to keep putting things out there, and constantly changing things. The builders wanted something that was stable. That's why they were asking for an ANSI standard. They wanted something stable. The ICC needed something that was stable, that they could point to that version and go, we got this for the next 3 years. And now the HERS index is not doing that. The HERS index has introduced more instability than we had before. And it's the way they're developing the standards. And that's when they're developing the standards like that, it's changing it so that the HERS index is always going to be different. And Ryan Mears pointed this out.
Oh yeah, no doubt. I totally agree.
They're always going to be different. It's not an ERI. They're always going to be out of sync. And that doesn't give a lot of confidence to code officials and frankly, home builders to the process when they're constantly getting a different number, depending on, which version of the software tool are we using. And that sucks.
Well, that's all over the place. That's not just on HERS calculations. That's on energy code performance calculations, on ERI calculations. That's on all of it. Every time there's a software update, we all know that it changes those thresholds in some form or fashion. And that's just something that the industry is going to have to contend with down the line. But I will say this, at least with the HERS index, there is a quality assurance standard backing it. There is a quality assurance standard and protocol to enforce it. I can't say the same thing for energy code compliance out there, as far as like who's out there as an independent third party running QA on all these inspections and tests and the calculations at the front end. So I do think that the HERS index does bring that to the table.
Yeah, until you have some cat like this, one provider that lets a guy who admits to committing fraud on code testing, and he's allowed to stay in the universe because it's in the best interest of everybody involved, including Resnet.
Yeah, no, we've had sidebar conversations about that, and that's plagued the industry for several years now. So
so I mean, you either have a robust QA system or you don't. And in this case, it seems like it's not a very robust system when that kind of stuff is actually called out in the Resnet registry of raters.
Yeah, but I mean, a system is better than no system. I would say that.
I would say a good system is better than no system.
I love it. I was hoping we would get some of this conversation. And again, I think all three of us, without a doubt, want better homes for people in Texas. And I mean, none of us three talking or the folks chiming in on the chat are trying to cut corners. And ultimately, you're just trying to make it easier for everybody and easier for the code officials. And it's problematic in a handful of ways. But again, with those backstops, I'm okay with it, but I just wish it wasn't problematic. I'll tell you what, it's nowhere near as problematic as this stucco install right here. I can guarantee you that.
Yeah. Every time I think about this, I think all these things with the energy stuff, I keep thinking, in the grand scheme of things, what's the point of all of this work that we do to make sure that the house is energy efficient and all the rest of that, when the fucking structure is going to fall down and rot in 5 years because the guy did something like this?
Right.
It's like, give me a break. I swear. So the Code of Hammurabi, which is the oldest known building code in the world, Babylonian emperor, he did something really interesting when he wrote his building codes. He said that if a builder builds a house and the house that he builds is not strong and it falls down and kills the homeowner, that builder shall be slain. And what I was always struck by that was that it was mandatory enforcement language because they used shall, and it was reciprocal. So if what kind of damage you did as a builder, well, you got the same, you paid the same consequences. And I was teaching a class in Nashville, Tennessee once, and I said that, and then I stopped and I looked at all the code officials because it was a classroom full of code officials, and I said, how many of you just thought of builders that you would like to drag out in the parking lot and shoot? Because they see stuff like this and it's really too late for them to put a stop to it. You know, like, how can you fix this? You know, it's so hard to fix now. It's almost impossible. And, you know, the reality is, you know, be looking for these details at plan review, get clarifications, force the designers of these homes to not do stupid things. And just remember that we can never outwit the human stupidity with a computer. People will always, every time I think I've made something idiot proof, God invents a better idiot. And it's just a pain in the neck, but that's the reality in which we live. You know, stupid shows up on the job site. You don't know when, but he's on your payroll somewhere, and he's going to show up on the job site. And when he decides to manifest stupidity, you don't know how bad it's going to get. And there's no computer program in the world can prevent that. But, you know, you can stay on top of it. You know, for example, there's a subdivision out near where I live. There's a second floor window. You can see there's a stud right in the middle of the window and fiberglass insulation on both sides. It's like, why didn't somebody catch that? And then they replicated it on every single model of that home that they built. There's like 1,000 of these floor plans, and every one of them's got a stud right in the middle of a window, insulation on both sides, covered up with drywall on the inside.
Oh, hey, this builder right here is going to build 200 to 300 homes this way this year.
Hopefully not. You know, I mean, like where was this, McAllen? Hopefully somebody down there is like, dude, redesign this.
Yeah, I'm trying, and they're trying, and ultimately, you know, when you roll up onto this job site, what are you going to make them do at this point?
I know. That's the point. Is it's kind of too late to catch it now.
Yeah,
you know, which is a lot of the way Resnet's QA system works. It's finding people after they've screwed something up and going, hey, you screwed this up, instead of helping to prevent them from making the mistake to begin with.
And those are some of the things that raters are such valuable assets to builders. I think raters enlarging their scope of building science and construction knowledge to some of these, you know, obviously working for an energy efficiency nonprofit, these resiliency aspects. Again, if this house right here has a great energy bill for the first 5 years before the wall falls down, well, that's great and all. But when you have to demo the house in 7 years, I don't know. I mean, anyway, I think that would be some great. Now, of course, builders don't want to hear it. The stucco guy doesn't want to hear it. That's a challenge. Which one was CT talking about? That one, maybe. But anyway, well, we are right on time. And I think with Brett, you know, adding the God always invents a better idiot, that's a good, considering we're right at 2:00 and you finished us off with that. I'll give you the final word if you have anything to add, Brett, and we'll call it a day.
Yeah, you know, my final word is this: the energy raters are a huge resource for code officials and builders. The question then becomes, how do you know if they're good energy raters or if they're sloppy energy raters? And you can get a sense of that from the way they work, and the work that you see, the reports that they see. You can get a sense of that. You know, are they substituting 3-inch brick veneer when it's really 2 3/4-inch brick veneer? You can look for that in the reports. These kinds of things are sort of like the little tells. And then, you know, the thing that I think would be absolutely critical for everybody to understand, and I want to be crystal clear on this: there's a lot of problems in the energy rating industry right now. There are ways to fix these problems, and these problems are being fixed. There are people out there who are working furiously to fix these problems. The process of the energy rating is valuable. The energy raters are valuable, but we must always remember the purpose of the measurement is not the result of the measurement. The purpose of the measurement is to help people build better homes, not just get a lower number, because you can get a lower number by fiddling with equations. But did we actually make improvements to the home to save energy, to reduce the cost to the consumer, to relieve the pressure on our grid, to do all of those wonderful things that the code calls for.
Amen. Perfect way to end it, because I couldn't have said it better myself. We'll stop with that. Thanks for joining us, everyone. A lot to chew on. We will post it on our YouTube channel. You will get a course evaluation with a copy of this 3215 and a copy of the original slides. Please don't hesitate to reach out. I know this is confusing, and it's going to be hard for a lot of jurisdictions to make decisions on this, and how are they going to do it? And it's going to be hard for the builders if some jurisdictions say yes and others say no. And I certainly feel for all sides, but ultimately, Brett said it perfectly there at the end. What we're trying to do is build better homes that last longer, that have lower utility bills, that are better for the consumer, that ultimately have better indoor air quality, and all of these things that come with. It's not about getting better numbers. It's about getting better homes. Thanks again, Brett. Always my favorite. Thanks again for joining us, everybody. We'll see you next time. Oh, and you'll get an email tomorrow. Thanks, everybody.